Go out to check on the fish. They seem to be doing pretty well. I've noticed the gold one, which very cleverly is named Goldie, which is Elise's fish, is kind of a scaredy fish. Like when I put my hand over the tank, like I'm gonna feed, she just takes off. The others, sometimes they do too, like what you just saw. But they a lot of the time they just think I'm gonna feed them, so they don't dart away or anything. But Goldie, the little goldfish, the true goldfish, I think it's a comet or maybe just a common goldfish. I don't know. She's quite the scaredy fish. She darts away quickly. We got all 6 happy campers so far. I've noticed that the 2 orange and black shabunkins, this one right here that we're looking at up close, is squirty fins, and then her friend right behind her in the back, that's Spider-Man, that's Nicholas's fish. Squirty fins is Veronica's fish. Those 2 in particular are little piggies. When there's food, they like muscle in to get it. They think it's a contest or something. The others are a little more relaxed about it. Millie's fish, Rainbow, which we call Rambo, because it's funny, and because it annoys Millie, and because if you look, he's got kind of a orange bandana across the top of his head, like Rambo does. She calls him Rainbow, but his name really is Rambo, I think. It's a very chill fish. Just kind of nothing gets too exciting for Rambo. Just floats around. I notice he's got on his right front fin, he's got kind of a gap there. I don't know if that was something it was born with or what, but I don't think that's a new injury. But anyway, these fish, I've noticed that there was quite a bit of algae on the rocks and on the surfaces and on the hose, and there's still some on the pump, but not nearly as bad as it was. These guys are just constantly foraging. I think goldfish by nature, they're like carp. They're ultimately they in the wild they would be bottom feeders, and so these guys are just constantly hunting around on the bottom, picking up rocks and licking the algae off and spitting it back out just over and over again. Like it's their life's goal, which I guess it probably is. Hey Goldie, how's it going? Anyway, so I'm pretty happy with how things are going in the fish tank. I think the fish are pretty happy. Not too upset with their lives. My radishes are doing pretty good. Now this is okra has finally come up. The celery and stuff on the side hasn't come up at all. I've seen the bean right in there. Its root is coming out. It just hasn't started sticking up a plant yet. And the pepper back in the back hasn't done anything. It wasn't even germinating back the last time I checked. So in here we're getting a little bit of action. These 2 plants in the middle haven't done anything yet, but these other 4 all have a little plant sticking up. I don't think it's ready. It's for transplanting yet, but I probably need to let them get some sun. So I guess it's time to just leave the cover off. Yeah, I might even actually take them in and put them under a light for the evening, because I don't want those cotyledons to die. In fact, this one is I've probably done it a disservice by letting it grow so long. It probably wouldn't be that long if it didn't think it was trying to reach up and find some sunlight. So probably need to get that stuff in, and I'll check out this other 2 to see if germination is started, and if not, I might just try again. I want to grow both of those two kinds of plants. Anyway, I've come out here today just to kind of check everything out, but also to work on. It's such a nice day, so I decided to come outside and work. I'm wanting to add some digital sensors to the tank and to the system, so I can check various levels of things, and have it report to some web service, either in the cloud or on my PC just here at home, since it's just a small project of mine. It's not like a big deal, but I want to add some sensors to check various things that could go wrong. In a typical aquaponics system, the thing that kills the most fish is if you have a catastrophic loss of power, and then either your water levels get screwed up, or there's not enough oxygen being put into the water, right? So like if you look, I've got both garden beds drain into the tank, and when the water splashes on the surface, that aerates to some degree, and adds oxygen to the water. But I've also got, you can see bubbles coming from the left side of the tank and then from the middle in the back. I've got a air stone connected to an air pump. In a big aquaponics setup, you have a lot of fish and not a lot of water, and if you don't have an incredible input of oxygen, then the fish suffocate and die. So actually, in a lot of commercial aquaponics systems, if they don't have a backup battery for their air pump, their fish just die instantly. So for me, that's not as big of a concern. I think as long as the pump, even there's a fair amount of surface area to the water, from, compared to the number, there's a small number of fish. So even if those air pumps weren't there, I don't think, if the air pump failed, I don't think that would be a real big problem here. At least not immediately. I think these 6 fish wouldn't consume all the oxygen all that quickly, but I don't know, I guess you could monitor it and make sure. But anyway, we've got I want to check one thing for me that is a fairly large concern, is that if I'm not looking at the system fairly frequently, it's possible that there'd be a leak in the garden beds or somewhere up in the upper apparatus. A substantial leak, something could happen, and that pump would just keep on pumping water out of the fish tank. And if the water wasn't coming back because there was a big leak or something, then that tank would just get pumped dry in a matter of probably about an hour. It would be dry, or close to it. The fish would be living in like an inch of water, and that pump would burn out, because I don't think it has a floater switch in it to turn off if the water doesn't, if the water level gets too low. I think it just would burn up because it's a cheap pump. Anyway, so that's one of my primary concerns, is that I don't have anything checking my water level. So I've decided to add some instrumentation to this setup by way of a Raspberry Pi. This is just a cheap project-y computer, I guess, you can buy for $30 or so, $35 I think. This is a version 3B, version 3B, I guess, which has a quad-core 1.2 gigahertz ARM processor, and HDMI video output, and audio output, and an Ethernet connector, and 4 USB ports. It's also got the Wi-Fi and Bluetooth on board, so it's built in. You don't have to add an external device or an antenna or anything. It just works. In fact, it's connected to my house Wi-Fi, and I've connected my laptop to it through an SSH terminal. And I'll do a quick demonstration of the temperature and depth sensors in a minute. But so I've got, currently I'm planning on adding 3 kinds of instrumentation. We've got these thermometer probes. They are a one-wire type probe, which means that you plug, so here's two of them connected. The red and black wires go to, the +5 and ground, respectively. But the two yellow wires, if you see here, are going into the same place. We've got a pull-up resistor here, which attaches to the 5 volts it's just a standard pull-up resistor. And then both of those are connected to the same single I/O pin on the Raspberry Pi. Pin 4, GPIO pin 4. Then there's the Linux kernel, there's a driver for one-wire stuff, and there's another driver for these thermometer type devices. And so it actually puts the information that the device is sending out into the file system. So you can just read the file, and it'll give you a text-based output, basically, of what the sensor is saying. And in fact, since these are multiple devices on the same pin, each device has its own serial number, and it indicates its serial number and the data that it wants to transmit. And they kind of take turns updating their information. So you can hook many devices all to the same output, or the same I/O pin, which is, if in a complex system, if you've got many sensors and just a single computer, there's a limited number of pins that the computer has available to read stuff. So it's nice in this case, you can overload that one pin with lots of data, and it might not be as fast, but it's not like you need to do microsecond updates. You're pulling data maybe once a second, once every 5 seconds, so it's not a huge problem to have many devices communicating all at the same time, or all on the same wire. So they have to take turns talking, but that's fine. So so I've got actually 5 of these probes. I got a 5-pack. It was pretty cheap. It was basically as cheap as the 3-pack, and I knew I wanted at least 2 sensors. But this is a stainless steel tip, basically, around the electronics and the probe itself. And this is water resistant, waterproof, I guess. You can submerge that in the water, it's no problem. And it still works just fine. So that's what I'm going to do. I'm going to have one down in the tank with the fish, one just under the table there, just an ambient air temperature, and then maybe put one up in the deep water culture bed to see if there's a difference in temperature between the tank and it. And if there's not, I might just leave it up in the tank, because I can just plug this, shove this through the raft and have it always touching the water, rather than have another wire dangling down in the fish tank all the time. Something for them to nibble on, or who knows what. But anyway, so that's the temperature thing. Then I've got this ultrasonic sensor board. Basically, the idea here is that you send a pulse, an ultrasonic pulse, which it might be audible to a dog, but it's not audible to humans or fish. So you send a pulse and wait for the pulse to come back. And the amount of time that it takes, since sound has a speed in air, if you know if you can tally how long the sound took to get from out the sensor and then back to the sensor, and then get the distance and divide that by 2, then you know how far the distance is between the sensor and the surface that it hit. So I can use that to get an approximate distance between the sensor and the surface of the water. I'll suspend the sensor pointed down over the surface of the water, and it'll bounce a sound wave out, send a little pulse to ping, off the surface of the water, and it'll tell me how the distance between the sensor and the water, is the inverse kind of the distance between the bottom of the tank and the top of the water. So that'll give us a relative, an approximate, at least a pretty good approximation of the water level and the change in water level. And we can set various limits to send alarms and that kind of thing. To one, say, hey, you need to add water to the tank, or hey, the water's going down at this rate, you need to check on a leak or something, you know, because we definitely, if the water starts leaving the system, I need to know about it and be able to fix it right away. So yeah, let's see. And the third sensor then is this is a pH level indicator. You can see inside between those 4 prongs, there's a little sphere, little glass sphere, and that's the sensor is in there. I don't know chemically how it works exactly, but I know that if you let the sensor dry out, the sensor is ruined. So it comes inside. This is just, it's in a little plastic cup full of a neutral pH solution. I think the pH is 7.5 or something like that. But then that is connected through this BNC cable to this little board. And this board basically takes the signal generated by the probe and turns it into an analog representation of the pH. And so in this case, if the input voltage is like 5 volts, you know, so you've got anywhere, any value you could get a value out anywhere between 0 and 5 volts. And in this case, 0 would indicate 0 pH, and 5 would indicate 14, and I guess 2.5 would indicate 7.5, or 7 pH of 7. Anyway, that's that system. The problem that I have with that, the reason that's not hooked up, is that this is an analog output, and the Raspberry Pi does not have an analog input. So I have to get an analog to digital converter, and one is in the mail. I'm gonna wire that up tomorrow as soon as it arrives, but for now, I have tested it with an Arduino, and it works fine. I've calibrated it. It works just fine. But I thought I'd do a quick demo of the temperature and distance using a little application for the ultrasonic. We can do that first since we're already here. So we've got this sensor. Let's put the sensor right here. And I'll run the test a couple times, but just so we can see. It's a little Python script, and it says it saw something at 22 centimeters. Oh, it's not working out for me. Up and enter 17.9. Get real close. 8.4. So basically, that is indicating the relative distance in centimeters from the device to whatever it hits. So it seems to work pretty well. I haven't done any exact measurements or anything to see how close it is, but it'll at least give me some kind of way. I could, I could use those values and just calibrate the sensor to see basically a rough estimate of the distance, and that's all that we really need. As long as we can translate, the values approximately, it'll stay fairly constant. I think at least it should give us a pretty good, a pretty acceptable estimate. That's all I'm worried about. So the other thing is the temperature sensors are on the file system. In this Linux system, it puts them literally in the file system. So we change directories to /sys /bus /w1 for one wire /devices. If we do a directory listing, we get 280316 blah blah blah. One of them 6B4, and the other one's 6B5. And so if we look inside those directories, 28, 31B, let's look at the first one, then 4, blah blah blah. And then do a listing. We get driver ID name, power, subsystem, U event, and W1 slave. So in this case, we can get the text that we want out of W1 slave. So we'll just look at that file cat W1 slave to the console, and we get some hexadecimal values that indicate that CRC equals 2F, and it says, yep, that's right. And then the next line says that T equals 20375. And so how you read that is that's 20.375 degrees Celsius. And then if we just do a quick calculation, we can do, what did I say, 20.375, 20.375 times 9 divided by 5 plus 32. And that's how you convert Celsius to Fahrenheit, and it claims it's 68.675 degrees, which is probably about right. It's a beautiful day. It feels about 68-ish to me. So yeah, I'd say that's probably exactly right. So anyway, that's it. I'm gonna have a couple temperature sensors constantly, keeping track of the temperature in the tank and in the air. I suspect the tank water will stay a little more constant than the other water, or than the air temperature. Air temperature changes a lot more rapidly than water does, but they'll correlate to some degree. And we'll have a pH, so we'll know if there's some kind of catastrophe, and then we'll have water levels, so we know that that I need to add more water, or that the tank is in danger of draining. So I think my next steps are, to get the pH system working on the Raspberry Pi, but then I need to start building a container to hold this thing safely, so that it's safe from the elements, and a strategy to run cables and solder everything together so it's not temporary like this and whatnot. But and then after that, I've got to get the software working on the Raspberry Pi so that it collects the data all the time and sends it off to somewhere else, to my PC or to the cloud, so that I can then, render that information and send warnings to my phone and whatnot as necessary. So anyway, should be a fun project. I'm looking forward to it. That's all for now.